time to build a circuit board, and it's going to be one of this small batch of BigClive.com circuit boards, as you've seen in the sort of like the thumbnail for this video. And when I designed this, I sort of added some extra frills, sort of finished it off. But then I decided, although I get offers every week from printed circuit board manufacturers, they want to send me free samples of circuit boards, I always kind of politely ignore those because I'd rather just go to circuit board manufacturers myself. It's not that expensive to get a small test batch done, particularly in the green and white, which is the standard colours of the prototype runs. And I decided, well, I'd rather actually get it. I'd rather pay for them because it's not that expensive and I get what you would get. It's more realistic. There's not going to be any special treatment. So I went to Seed Studios. I've used them before. I was quite happy with the service and ordered a batch of 10. And they arrived and I looked at them and thought, oh, right, there's a little sort of text they sometimes add a reference, but what's this little splot here? Is that in... Surely, oh, that's probably just a wee splash of the screen print. And took it off, and then the next one, it was like, oh, that's got the same. How did I manage to put in a file that has that? And then I went to the next one, and it's not got it. And it's not got it, it's not got it. And then there's another one appears. And it turns out that of the 10 circuit boards, there are 4 limited edition bonus peanut ones, which have that little peanut feature on them. And I'm guessing that because these are made in batches of circuit boards that share, instead of actually just doing a single run, for you as such, they'll put your circuit board on a sort of panel and run several batches of those panels, and then your circuit boards all get taken off afterwards. And that's also why the default colour is usually green circuit board with the white screen print. And there are other colours, but as soon as you deviate from the standard, the price and quantities all vary. They go through, it's more like aiming at a batch of 100 circuit boards or so. I think JLC PCB offer more colours in the small batch. I guess really they must just want enough people to order at the same time in one colour that they don't have to keep changing the colours all the time. But anyway, I have 10 of these circuit boards, but then I discovered something else that was quite interesting. I put the circuit, the socket in the first one in, and it didn't go in very well. And these 2 holes here, there are 1, 2, 3, 4, 5, 6 holes in the circuit board. There's 1 at each corner that's 3mm, and there's 2 up here that are 1mm, except if I put this little 1mm pin, it goes through one of them easily. It doesn't go through the other one easily. It's got a tolerance issue in those. And initially I sort of thought it was my fault again, that I'd done what I usually do when I design circuit boards and I'm going to etch out prototypes, like say for instance this prototype of this circuit board, which has all the different styles of LEDs on it that I was using to test which looked the best. What I'll usually do is the holes, even the sort of the corner 3mm holes, I'll just do it as a tiny sort of 0.5, 0.8mm hole, purely because it helps align the drill up in the copper pad. And I thought initially that I'd just forgotten to change one of them, because sometimes I'll highlight it and go, usually when I'm going to manufacture, I'll highlight each pad in the design that I want to adjust the size of, and then I'll just change it from its original size up to, in this case, 3mm, in the case these 1mm. And I went and looked at the original circuit board design, thought I clearly missed one, but I hadn't. So then I looked at let's tame this down. Then I looked at the drill file, and the drill file format is like this. It's a script, it's a text file that describes all the drill sizes. So it lists inches, and it's got 2 drill sizes. It's got 0.039 is 0.99mm. That's the size in inches. And drill 2 equates to 2.997. So that's the 1mm one, that's the 3mm one. So there are only 2 drill sizes specified, and if you come down here, it says drill 1 T01, and it lists 2 hole positions, and TO2, which is the 3mm, it lists the 4 XY coordinate for the 3mm holes at the sides. It's interesting to see the format of this as well. I shall brighten the image back up again. There we go. So yeah, it's a bit quirky, but that's okay. It's nothing that can't be resolved. And I'm going to be giving these circuit boards away. I'm going to be giving them away as kits, but I'm also going to be building one of them for myself and building one, probably, and sending it, if they actually want it built, to Clive Willoughby. Clive Willoughby, who's not in the best of health at the moment, so I'm going to send him one of these circuit boards as a gift and also mention him on the channel, which I'm doing right now. So I hope things are okay at the moment, Clive. I know things aren't great health-wise at the moment, but hopefully this will be something you like. And let's start making the circuit boards. Oh, if you want one of these, then most of them are going to the PayPal and Patreon supporters. But if you want one of these, then leave a message down below in the comments. You can add peanut for one of the limited edition peanut ones, or no peanut if you don't want the peanut feature. And I shall start making one of these right now. So let's get the soldering iron on. This is where it does that annoying thing that, because the soldering iron transformer bumps in and out, and because of the noise gate in this camera, it's a Moto G6 Play, it does this annoying thing that it just, at low levels, when I'm not talking, you'll hear the transformer noise will make the microphone cut in and out at low level. It's an annoying feature. No matter what camera I get, it's just got a feature that just isn't YouTube compatible. It's just how it goes. When I send these out, I shall solder all these sockets on, not just to actually resolve the issue with the holes, but also because I think that's the most likely time that something's going to go terribly wrong, that, you know, something could go into some solder could go inside and wreck it. So I'll solder those all on before I actually send it out. And send the LEDs and resistors. The LEDs are from China. Hopefully they'll be decent. I didn't go for the cheapest because I was hoping that by paying a bit more I'd get decent ones. The resistors are also from China, but they're actually via Rapid Electronics in the UK, where I bought a roll of 5,000 resistors. So I think I've got plenty of resistors. Let's open the LEDs. And this is where I'm going to use my maker knife. I'd like to thank Kane for sending me this. I mentioned in a previous video that I'd really fancied one of those, but kind of missed the boat with that campaign that Gyako whatever ran. They actually they feature the maker knife on their website, on their YouTube channel. The whole process of actually even going to China and actually making it. It's quite neat. It's a knife that takes standard Stanley blades, but they lock. It locks solidly out until you put your finger in here and pull it back, and that unlocks it. And likewise, you can just flick it straight back out again. It's a very neat design. So thanks for that, Kane. I feel a bit awkward. I feel like that was really super generous. So let's use it for the first time to slit open this pack of LEDs and start making things. And this is also a good time that I could bring up my Trumpy brick again to actually raise this up closer to the camera and then zoom down for this. So let's bring in the... Yeah, someone pointed out that this is the brick that came from Poundland. It's a foam brick. When America was running its elections, they put loads of stuff out. It was for American parties. And, you know, it was American-themed parties during the election. This is what happens in Britain. They have themed parties. And they've actually got a question mark at the end of it, some pointed out. But I'm not sure. I'm not sure this would be very good for building walls. For reasons of being rubber, basically. It would be a safe wall, very safe wall. So I'm going to zoom down here. And I'm going to start soldering the things in. And I'm going to also go over a few features of this circuit board. These are all the resistors. These are resistors as well, but these ones with one big, huge box around them are just practice pads if you want to practice. The LEDs around the outside, the negative is on the outside in all cases, and there's a wee chamfer from the edge of the track for that, just to show that that is the negative connection. And that's about it. These are just superfluous things I added in the middle just because I could, including that rather fetching little mini silver play button. This would, technically speaking, have been a really good idea to release the circuit board around about 100,000 viewers, wouldn't it? For the little mini silver play button. But I didn't. I'm not that organised. So let's start soldering. And if it starts taking too long or I run out of things to say, I'll just pause momentarily while I put this together. So I'm going to do what I did last time. And I'm going to run the solder onto one side only. And then I'm going to place the components on and reflow the solder. And then add a wee touch of solder afterwards. But let's see if I can not make the mistake I did last time. That as I kept rotating the circuit board around, I lost track of which ones I needed to reflow. It seems so far to be a fairly easy circuit board to make. Famous last words. This is where I could have actually done a questions and answers again. So let's bring in the resistors. This is, as the reel comes, it comes with a sort of leader with no resistors at all in the sort of leader section for at least one revolution. I wonder if that's just for humidity control or actually, you know what? It will be so they can prime the machine. So there are no resistors until it goes quite far in. So let's peel that strip back. I'll just zoom out while I'm doing this just because it's a bit off shot. This is where the resistors just suddenly go everywhere. I chose 220 ohm resistors just as a reasonably good value for the task. And here they come. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've lost count already. I'll just put a pile down there and I can always put them in a container afterwards and I shall get this out of the way. That's quite a lot of resistors. That's probably more resistors than I need, but that's okay. Let's bring in, I've got a choice here. I could use the standard stainless steel tweezers, which are okay, but they feel a bit springy. When you squeeze them together, it doesn't let you apply them to anything with significant force. I don't think that's really, let's try both. That's the best bet, isn't it? So I'm going to zoom partially up on this and start soldering these, and I will start initially by using the stainless steel tweezers. I should have actually checked the resistor value, shouldn't I? But I didn't. I'm not sure about that. I've just tombstoned that. Not quite tombstoned it, but it's just skewed round with the surface tension. Maybe I'll go for the ceramic ones. If you want ceramic tweezers, just go on eBay and search for ceramic tweezers. They're very useful. The main advantage of them is that they grip really well, because when your fingers are close to that, you've got the fairly solid ceramic, and also they don't hold magnetic field, or a magnetic residual, field, I suppose, really. Residual magnetism. So I shall start putting these in. I was a bit premature in taking the soldering iron away there. I shall try that again. I really should check the value of these resistors. Let's get a little magnifying glass and take a closer look at those. 2200. Wow, why has it got 4 numbers on it? I wasn't expecting that. Excuse me while I get the meter in and check this out. Let's put this up to 2000 ohm setting and just check those resistors are 220 ohm. Yeah, that's fine. Hold on. 220 ohm. Good enough, that's fine. Give or take a bit of tolerance. So 4 digit resistors, 2200, that's 220 and a 0 multiplier after it, so it is 220 ohm. Okay, that's fine. I'm not putting them all around the same way, partly because I can't see the numbers easily. So I'll just keep splatting these resistors on. Things to talk about while I'm doing this. There's a good one. Someone was asking about, a few people have suggested I record books for Audible. They think I've got a good speaking voice. Not really sure. What I can tell you is I failed O-level English twice when I was at school, to the consternation of the teachers. I think I've mentioned this before. It's just something that riles me a little bit. The reason I failed O-level English was because in Britain, Shakespeare English was taught. I'm not sure why. It wasn't just a case of can you read or write. It was a case of can you speak Shakespearean English. And to be honest, I wasn't really into Shakespeare. So I didn't do very well in my English exams. Generally speaking, I don't think people tend to say things like, "Hitherto to them, my good lady, whence it is to be that onest might fondle my groin," and on and on. Another thing they did was weird poems, and I'm not into poetry either. But it wasn't a case of, why did they even call this English? It should have been called literature. But they were judging kids' ability to speak and write on this bizarre choice of material. And it wasn't just poems that they covered, but it was they chose artistic special poems. Poems that don't actually rhyme, as a matter of fact, which aren't very fun for a kid. The main subject was based around a poem called My Last Duchess. And what was so special about that poem was that it didn't rhyme until it was halfway through the next line, I believe, and that just made it arduous. So when it came to the test, when it actually came to the exams, they did kind of say you really just should just do all this stuff beforehand, cheat basically by rehearsing and doing all this stuff before the exam itself. I didn't really understand that concept. I thought an exam was supposed to be a raw test of your ability to do something. So I went in and tried to do the exams completely fresh and unrehearsed, and trying to, for instance, one of the things they do is they make you write a short story, and you get 1 hour to write a short story under exam conditions. And if I could write a short story under exam conditions in an hour, I'd be writing basically a book every 2 days. It doesn't happen. You can't just walk in and write a story. So I failed O-level English, and the English teachers were mortified because they knew I read an awful lot of books. I just read all the time, and they encouraged me by giving me books like War of the Worlds and things like that. But I failed. They got me to study at higher level, thinking I'd go through it and get both higher and O-level at the same time the next year, but no, I didn't. It was kind of upsetting because it's a big thing when you're a school kid. Let's drop some of these resistors randomly from a height to see if I can turn them over. Ooh, rubbery. And I thought maybe it was going to affect the career. But fortunately, the company I served my apprenticeship with, they had already given me the job before I'd got the exam results back. I never actually had to give the exam results to them. Latterly, it did affect me in one company. I approached a company called Maersk, a shipping company. I had the idea that, having gone so far in electrical stuff, I thought it'd be quite interesting. Joining the Merchant Navy and learning the engineering side of things. And I got knocked back because I didn't have O-level English. Makes me wonder how many other good, technically competent people they knocked back because they were forced to study Shakespearean literature at school and didn't really click with it. I guess there's a bit of flux in the tip of these tweezers because it does occasionally stick the resistor to it. Another company I applied to, but it didn't even get that far, was Alcan in Glasgow. They had a sort of like a rolling mill, and they advertised for a maintenance electrician, and they were also looking for a maintenance electronic engineer. And I went up to the reception and said, can I actually apply for both of them, because I could fill both roles. You could choose one or the other, so to speak. And the women reception got another woman from the Human Resources Department, and she came through and said, before we go any further, do you have an HNC or an HND or whatever it is? And I said, no, I don't. I've got the standard sort of trade qualifications. And she said, oh, you'll need to have an HNC or we won't consider you. And I said, what in? And she said, well, anything really. So on that basis, were they really just looking for students who'd studied absolutely anything? I don't know. Very strange. It's not there anymore at Alcan. It didn't seem to be there for very long. Maybe they employed a philosophy student or something like that to do the electronic repairs and all the machines broke down or something. Dunno. Very strange. I've always been of the opinion that if you're interviewing someone to employ them, the best thing to do at the interview is have someone who understands the technology to ask them technical questions, because you can tell an awful lot about someone's technical ability just by talking to them and talking technical. These resistors are flying on. That's pretty good. Or is it just because I'm rambling on? I have a new recording device, but I'm not going to reveal what it is yet because there are issues. It's another phone. It's a very capable phone. I'll give you a clue. It can record thermal imaging as well. It can record video. Unfortunately, it's got huge problems with its ability to record normal video. It glitches all the time. If you use a third-party app like Open Camera with it, and you're just making video like this, if I was to actually record with it and I was just to basically run my finger backwards and forwards, it looks smooth enough on this camera, but if I was recording it on the other one, the other device, it looks like this. The finger would go across, then it would suddenly jump, and it just pause and jump, and it seems to be dropping an awful lot of frames. It doesn't seem to do it with the actual native camera app with the phone, but it's not actually suited to recording for what I'm doing at the moment because it doesn't seem to have a way to disable autofocus. It just keeps pounding away in the background. I'm going to reflow all these outer joints. Let's see if I can get a better score than I did last time, when I did have a few dry joints onto the surface mount components. It's just a thing, you know. You'll find most photographers have lots of different cameras. It's not because they're collecting cameras, it's because each one has its strengths and weaknesses. And as Casey Neistat says, it's just like the camera manufacturers. They just say, let's almost make a perfect camera, but we'll just stop just short of it being perfect. And that's exactly what it's like when you're recording for YouTube. Lots of different devices. I like using a phone to record video because it's designed to work with YouTube. It is the native YouTube recording device. I'm going to solder this socket on. This is where it could all go horribly wrong. Let's see if I can not flood solder inside the socket. I want to heat it enough that it flows onto the side of the case. I like to give USB sockets an awful lot of support. So I deliberately added a big pad to flow solder directly up onto the side of the case so that it locks it firmly in place. I won't heat it too much in case it melts the plastic inside. And I shall also solder the pins at the back for that. There's the negative one and there's the positive one. Right, I'm ready for the LEDs now. This is going together quite quickly. Oh, there's another thing that's worth saying about my little gripe about being forced to learn English literature for instead of just normal, you know, like English. I know I'm not the only one who failed O-level English. I know a lot of really technically competent people who don't have O-level English for exactly the same reason. That is just a bit annoying. It kind of suggests that their education system has failed there. It's just how it is over here. It's another thing that riles me about courses, that you go in a technical course, and I tried to do a correspondence course when I was with Hussman for refrigeration because I just thought it would be interesting to update my knowledge in that sort of area. I'm just going to cut a bunch of these off. And the course was just really not intuitive at all. It was arduous to actually do it. It shouldn't have been arduous, but just the way they designed the course it was. Well, that worked. Pinging LEDs everywhere. Right. So I see a little green dot and a line. I'm guessing, well, this is going to be very, very tricky. I'm going to try this for polarity before I do anything else. I can see a wee dot of green there, and there's a little sort of arrow pointing there, so let's see if I can make this light. We'll bring the meter in, and we'll stick the meter to the diode test because it passes just enough current to make that glow. Yep, that's glowing. Perfect. The polarity check has been done. So now I'm going to run a bit of solder onto all the outer pads again. Did I finish what I was talking about there? I know a lot of people who are really technically competent who didn't get good results with English at school. And if you employ people, keep that in mind that some really good engineers may not have the box-ticking O-level English, but if you talk to them or you get them to write stuff down or if you email them, you'll find that they're actually completely 100% literate. They're absolutely fine that way. It's just keep in mind that the exam system from the past wasn't really perfect. It was a bit detached from reality. It does make me wonder if people have had the chance of a good technical career taken from them as a result of things like that. Such is life. Right, let us pick this LED up and we'll start soldering LEDs in. I've just dabbed my soldering iron on something that I didn't want to dab it on. I've just melted plastic, that's alright. Oh, yeah, this is where it's all going to get very awkward, isn't it? It does have a little dot of green at one side. I'll just keep checking that I don't want to actually screw this up and put the LEDs in the wrong way around. So there's the first LED. It's not perfectly straight. It doesn't need to be perfectly straight. It will still light absolutely fine. And if you are interviewing people for a job, yeah, just the best possible interview for a technical job is to get someone technical to talk tech. I've said that in the past. I'll say it again. That guarantees an accurate result because it doesn't matter how many qualifications they've got. If they can't answer simple technical questions, that's kind of an indication they may not be technically inclined. That one is slightly squint over there. I've got an urge to go back to that one and tweak it, but I'm not going to because I'll just mess up even further. School days. Yeah, best forgotten to be honest. Didn't enjoy school. It was like prison. There's another thing that's worth mentioning. Young people, now thanks to health and safety, you can't take your kid to work with you if you work in technical stuff because it's considered that you might endanger the life of a junior. When in reality, kids at a young age, helping their dads during school holidays and things like that, it served two functions. The kid would usually enjoy working with its dad on technical stuff. It would be learning an awful lot. And it would mean that the kid wasn't kind of being left on its own because it could actually join its dad at work. It makes me think of a friend who is a lift engineer who, when he was young, his dad took him into work and had him holding in loud, noisy electrical arcing contactors with the end of a cigarette packet as insulation. Perhaps not that extreme. These are very footery, but having said that, it doesn't matter. That's how surface mount components are. Ew. No point pausing now because I'll just think of something else to talk about then, will I? I'm kind of engrossed. Or is that engrossed? Maybe I am illiterate. I would say engrossed. It's one of those things, sometimes multiple people will say the same word and everybody pronounces it differently. You say tomato and I say tomato. So other manufacturers for the circuit boards, there's quite a few. PCB GoGo, GLC PCB, PCB Cart. PCB Cart actually looking a bit kind of expensive these days compared to the other ones. The price of having circuit boards has plummeted. It used to be a complex and expensive thing. I can recall when getting a chunky circuit board cost about £20 per circuit board when they were being made by UK companies. Initially, I tried when I started making my kits to keep manufacturing within the UK by using a British company, a European company actually. It turned out that they were just shipping them across. They were shipping the files across to China and then getting them bulk shipped back and then shipping them locally within the country. So I found that out because I got an email from a Chinese individual saying that they'd set up their manufacturing facility in China, and they must have had access to the full customer database. And they said, just so you know, I can do it cheaper just if you want to bypass them. But in reality, I thought, are they really manufacture them in China? In that case, I'll just go direct to a Chinese manufacturer, which is what I did. It was a bit more complicated in the early days. I have to say that the Seed Studio and GLC PCB, they've got a really nice thing that you can upload your files and it will immediately show you the sort of Gerber image, what they're going to look like. That's really advantageous to them, and it's kind of advantageous to you because you know how it's going to turn out and you can see errors before they go to production. I will say the GLC PCB had a bit of a glitch though. I looked at getting that, but when it realised this was a single-sided circuit board because it only had one copper, it decided it only needed one screen print side as well, and that kind of, it just wouldn't even recognise that that other file was there in their Gerber viewer. Is it Gerber or Gerber? Don't know. I would guess maybe Gerber. GLC PCB also had a glitch in their website that when I went to the sort of final payment page, it was clear that some kind of pop-up had tried to appear over the top, but because it didn't quite make it, it kind of greyed out the screen. You couldn't go any further. Maybe I should have told them that. I tried it on 2 computers. I get a feeling it might have been incompatibility with Chrome, because I use a Chromebook for my main internet browsing and I use the Chrome browser on my PC. So it might be a Chrome thing. That sometimes happens. You just find that a website isn't quite universal. It doesn't work with some browsers, particularly when it's quite complex. There's an advert plays in the radio locally. I hear it occasionally at the gym. And it's a company saying, do you remember when the internet was like this? And then they play sort of dial-up noises. And your website was this, and then it's a hee-haw sort of donkey noise. And it says, well, use our services and your internet will go like this. And it's like sounds of rockets. And in reality, all I can think of when I hear that is bloatware, just bloated websites that just don't work in some browsers. There was a lot to be said for the old ones, like mine. It will work in almost every browser. Don't know of any browser it doesn't work on because it is written in raw HTML. I'm almost done with soldering these LEDs, he said, letting go of the LED before the soldered cooled. There we go. One more LED. Do you think I'll have put any the wrong way around? I don't think I've put in the wrong way around, but I'll find out when I solder at other ends. And then plug it into a USB connector. Right, let's get some solder and flow these other connections. Push right up against the LED so it mates completely and get some flux from the solder in there. Standard 60-40 tin lead solder with flux core. Some of you have been getting cheap eBay solder and it's not been working properly. I wonder if that's because the flux in the middle of this, when you put the soldering iron on, a little flux comes up, the sort of wisps of the fluxy vapour. It's the flux vaporizing, it boils off and it chemically prepares the contacts, it deoxidizes them, it cleans them and lets the solder mate on. I get the feeling that some of the solder that's being sold online is from solder manufacturers. It's the bad batch where they were just basically priming the flux mechanism that puts the flux into the core. And it's maybe not quite got either any flux or the flux is intermittent, because people say they try soldering with some of that cheap solder and it just forms dry joints and then it suddenly works and then it's back to dry joints again. The question is, are you getting this sort of little plume of vapour coming off it when it's doing that? I do have a selection of Chinese solders I bought from eBay. I guess all of it probably comes from China. Give that a wee wipe. we're almost there. I shall retin all the outside pads of the LEDs, and if I'm very, very lucky, every single LED will light. Think I'll be lucky? I didn't actually need to rotate it like that, but I did. I'm going to reflow these with a touch of fresh solder for the flux alone. Because I flowed the solder on initially to these pads before putting the LEDs on, that flux will have boiled off. So although it tacked them in place, it's probably worth reflowing it just that tiny little bit, just to add some flux on and make sure it mates up completely. And just put the solder iron up till it touches the LED and the pad simultaneously, so that they are both raised up to the same temperature at the same time and the solder flows. Almost there. This is quite easy to put together. It's quite enjoyable to put together as well. It's a nice little project. So what we'll do, if you leave it down below your comment, peanut or no peanut, the one I'm going to keep is going to be a peanut one, limited edition. Then I shall pick a winner or two, and then mention them in a future video, or try and, if I can't contact them directly via the comments. It's a wee bit harder to contact people via the comments now. It used to be easier. They used to get notifications from when I actually responded to their comment. So let's plug this in. Is this going to be a complete disaster? You know I have to release it if it is a disaster. It's every single LED is lit. That's a good start. Let's go back down onto the sort of bench. It's looking quite nice actually, the sort of pattern that's coming around the edge. I'm going to jack this up on printed circuit board feet. Just give me a moment, I'm going to hunt some out. Okay, found them. I've used little hex spacers with a nut on top. And that is it. Let's see how it looks if I dim it down like that. This is where it's going to swamp out, isn't it? Yes, it is. It's going to blaze out. It's quite nice. Puts a nice halo. You can see the logo on top, but you also get the green coming through as a pattern round the outside. It's actually quite ferocious. Can I tame this down? Can I do something? Let's see if I can actually get a sort of emulate, get the exposure to actually give a convincing effect here. So I'm going to bring in a bit of light, tame that down a bit. Is that going to do it? That is close to what I'm getting. Yeah, that's more accurate. By tricking the exposure, that's a good result. Ooh, bright. Very easy to put together as well. Yeah, I like that. That's definitely a nice result. So, as I say, I'm going to be sending... We'll run a competition in this video. If you just leave your comment down below, peanut or no peanut, and I'll choose a winner. One's going to Clive Willoughby, and I'm keeping one, and the rest are going to PayPal and Patreon supporters. So that's it. The Big Clive LED illuminated micro USB coaster.